Dashi. My student ID is 101261322. This is assignment 3. So for the part A, we're gonna import all the required like packages and libraries. Then we're gonna import the image from the internet, and this is the visualizing the photo. This is basically how computer understands this photo. Then we put it to an array between 0 and 255, and this is how the image visualized, and we see it's a Lamborghini, a cool car. So yeah, this is when we put it in the array between 0 and 255. Then we're gonna reprint the shape and the value of the color channel and changing the values here. As you can see, it's like channel 1 and channel 2. Then when we save the color channel 0 in the input image array variables and print it like this, and then we're gonna again changing the value, as you can see right here. For conventional, we create the kernels here and applying our kernel, getting like this is the shape and this is the array shape and the padded shape. Then the car looks like this after we applying the kernel. And for the standard kernel, we apply the filter to horizontal lines. So it's right here. So it's for line detection. We applying for horizontal lines. And question 1A and 1B asks us about the so this is actually how the 45 this we make our kernel, and it recognized the lines with 45 degrees, and it shows like this for and we do the same with 135 kernel. We make the kernel, then we apply it. So this is how it's looked like for 45 degrees, and this is how it looks like for 135. It's kind of like flipping this ones, and we are focusing more on edges. Next steps, yeah, it's like more edges, for more edges and like internal textures. For part B, we're gonna then importing more necessary packages and libraries. Then we're gonna train our data, then loading and normalizing our data here, and we are going to, after that, we are building the neural network model right here. Then we compiling it, displaying the summary of the model. This is the 5 layers, and custom, and we are calling back here, and then we are running it. Then with 50 epochs, we are training model. These are all gave us pre-made to the assignment. And this is how the data works. The accuracy until kernel 20, they are going kind of like together, as you can see better in this plotting. So it kind of goes with each other to the like around 6 right here. But then the validation goes the training goes up, but the validation remains slightly upper and then goes the same. And so the question 3 asking us, did the network present sign of overfitting? If so, in which epoch? Well, the train is showing signs of overfitting because when it's starting around when it starts around like epoch 20, but where training accuracy kept increasing but validation accuracy began to decline. So it's around 20. As you can see, the train accuracy and the it's like going so close to each other, but from epoch 25 it still remain almost the same, but the training goes upper and upper. So this is the sign of overfitting. Write down how many layers this model has and identify their type. It's conv 2D, it's max pooling 2D, which is a pooling layer, flatten layer, the fully connected dense layer with 128 units and output with 10 units. It's like, as you can see right here, these are the output for this example. And if I wanna say briefly the purpose of each layers for question 5, Conv2D detects local patterns like edges, textures in the image using conventional filters. Max pooling 2D reduce the spatial dimensions of the feature maps, making model faster and helping prevent overfitting. Flatten converts the 2D featured map into 1D vector to prepare for the dense layer, as it's like right here. And sorry, um, okay, and we have 128 neurons and 10 neurons, which 128 fully connect the layer that learns high level features and patterns from the image, while the 10 neurons output layer that gives the final class probabilities for 10 Cepher 10 categories using softmax activation. And for the question 6, we should add one more convolution layer to model and run it again. So we are adding layer here, padding the same. Unfortunately, I did this assignment once, but I thought I can take the video later. When I wanted to take the video, the saving failed, and although I had all the letters here, but I got an error. I tried to do all of them together, but I thought I have enough time, but it shows that I don't have enough time. As you can see, the data, and it's 11:35. So the data is compiling and training again. Uh, Again for 50 epochs. And yeah, as you can see, this time is slightly better, uh, a little bit better than the last time. So I remember the plot was still the same, and I answered the question, compared the result between Oriental and model, and this one, the bigger model with at least extra layer added. So the original model achieved the validation accuracy of 66 before overfitting started. The modified model with extra conventional layer reached a higher peak validation, around like 71%, which was slightly better, which shows Another layer helps model learn more complex patterns and features from the image and improves overall. But large model also began to overfit earlier as training accuracy kept increasing while validation accuracy, uh, as you can see, uh, validation and training are not going together. Uh, and yeah, this indicates a trade-off. Deeper model can improve accuracy but require more regularization or data to avoid overfitting. Um, and for eighth question, um, I also trained my data, adding another layer. I also um, I put the dropout for 25 for reducing overfitting here, and this time the accuracy, the validation, the training and validation was going much more better together, and they were going more along. When you stop training, it gets out of shape, it gets lazy, and it gets uh, yeah, it gets more out of shape. But they go together when you are adding more layers, like the dropout layer. And dropout layer helps prevent to overfit randomly, deactivating a set of percentage of neurons during each training step. This forces the model to not rely too heavily on specific neurons and encouraging it to learn more robots and generalizing feature, which improves performance on new unseen data. And I really wanted to show this, and I did it once, but I got this error, and as you can see, uh, these are my results for 28th, but I'm not able to show it unfortunately because uh, all by sudden, because I left the video for today, and I thought if I don't if I leave the video for today is okay, but unfortunately I got this error and I had to run it again, and it take me almost 5 hours that running this data, and it doesn't show any sign of yeah, this is my video, and thanks for your precious time.